Now let's begin with the similar triangle. Let's see how to construct a similar triangle to a given triangle. For a given one-to-one correspondence between the vertices of two triangles, if their corresponding angles are congruent and corresponding sides are in proportion, then these two triangles are called similar triangles. Using these properties, we should construct similar triangle to the given triangle. Let's look at few examples. Example 1. Triangle ABC is similar to triangle PQR. In triangle ABC, AB is equal to 3.6 centimeters, BC is equal to 4 centimeters, and AC is equal to 4.2 centimeters. The corresponding sides of triangle ABC and triangle PQR are in the ratio of 2:3. Construct triangle PQR. Solution. Here, it is given that triangle ABC is similar to triangle PQR. Therefore, AB upon PQ is equal to BC upon QR is equal to AC upon PR is equal to 2/3. Now let's find the measures of sides PQ, QR and PR one by one. To find the length of PQ, it is given that AB upon PQ is equal to 2/3. Now, by substituting the value of AB as 3.6, we get 3.6 upon PQ is equal to 2/3. Now, by cross multiplying, we get 3.6 into 3 is equal to 2 into PQ. Therefore, 3.6 into 3/2 is equal to PQ. 10.8 upon 2 is equal to PQ. Therefore, 5.4 is equal to PQ. Thus, PQ is equal to 5.4. To find the length of QR, it is given that BC upon QR is equal to 2/3. Now, by substituting the value of BC as 4, we get 4 upon QR is equal to 2/3. Now, by cross multiplying, we get 4 into 3 is equal to 2 into QR. Therefore, 4 into 3/2 is equal to QR. 12/2 is equal to QR. Therefore, 6 is equal to QR. Thus, QR is equal to 6. Lastly, to find the length of PR, it is given that AC upon PR is equal to 2/3. Now, by substituting the value of AC as 4.2, we get 4.2 upon PR is equal to 2/3. Now, by cross multiplying, we get 4.2 into 3 is equal to 2 into PR. Therefore, 4.2 into 3/2 is equal to PR. 12.6 upon 2 is equal to PR. Therefore, 6.3 is equal to PR. Thus, PR is equal to 6.3. Now, let's look at the construction. Draw a segment PR of 6.3 centimeters. Keep the point of compass on point R and taking 6 centimeters as measure, cut an arc. Now, keeping the point of compass on point P with 5.4 centimeters, cut the previous mark. Mark the point of intersection of both the arcs as Q. Now join PQ and QR. Thus, triangle PQR is the required triangle. Example 2. Triangle RST is similar to triangle UAY. In triangle RST, RS is equal to 6 centimeters. Angle S is equal to 50 degrees and ST is equal to 7.5 centimeters. The corresponding sides of triangle RST and triangle UAY are in the ratio of 5:4. Construct triangle UAY. Solution. Here it is given that triangle RST is similar to triangle UAY. Therefore, RS upon UA is equal to ST upon AY is equal to RT upon UY is equal to 5/4. And as angle A and angle S are congruent, so their measure would be also same, that is 50 degrees. Here we got the measure of one angle. Now let's find the measures of sides UA and AY. To find the length of UA, it is given that RS upon UA is equal to 5/4. Now, by substituting the value of RS as 6, we get 6 upon UA is equal to 5/4. Therefore, 6 into 4 is equal to 5 into UA. Therefore, 24 divided by 5 is equal to UA. Therefore, 4.8 is equal to UA. Thus, UA is equal to 4.8. To find the length of AY, it is given that ST upon AY is equal to 5/4. Now, by substituting the value of ST as 7.5, we get 7.5 upon AY is equal to 5/4. Therefore, 7.5 into 4 is equal to 5 into AY. Therefore, 30 divided by 5 is equal to AY. Therefore, 6 is equal to AY. Thus, AY is equal to 6. In triangle UAY, UA is equal to 4.8 centimeters. AY is equal to 6 centimeters and angle A is equal to 50 degrees. Now let's look at the construction. Draw a segment UA of 4.8 centimeters. Keep the protractor on point, measure 50 degrees and draw angle A. Now, taking 6 centimeters as measure and keeping the point of compass on angle A, cut an arc. Mark that point as Y. Now join UY. Thus, we get the required angle UAY. Example 3. Triangle RKN is similar to triangle SPV. In triangle RKN, RK is equal to 6.4 centimeters. Angle R is equal to 60 degrees, angle K is equal to 50 degrees and Rn upon SV is equal to 4/3. Then construct triangle. Solution. It is given that triangle RKN is similar to triangle SPV. Therefore, RK upon SP is equal to KN upon PV is equal to Rn upon SV is equal to 4/3. Here, angle R and angle S are congruent, so their measure would also be same, that is 60 degrees, and angle K and angle P are congruent, so their measure would also be same, that is 50 degrees. Here we got the measure of two angles. Now let's find the measure of side SP. To find the length of SP, it is given that RK upon SP is equal to 4 upon 3. Therefore, 6.4 upon SP is equal to 4 upon 3. Therefore, 19.2 upon 4 is equal to SP. Therefore, 4.8 is equal to SP. Thus, in triangle SPV, angle S is equal to 60 degrees. SP is equal to 4.8 centimeters and angle P is equal to 50 degrees. Now let's begin the construction. Draw a segment SP of 4.8 centimeters. Keep the protractor on point S. Measure 60 degrees and draw angle S. Now again keep the protractor on point P. Measure 50 degrees and draw angle P. Let the point of intersection of both the angles be point V. Thus, we get the required triangle SPV. Example 4. Triangle PSE is similar to triangle TSV. In triangle PSE, SP is equal to 4.4 centimeters. SE is equal to 5.1 centimeters. PE is equal to 5.5 centimeters. And PS upon TS is equal to 5 upon 3. Construct triangle TSV. Solution. Draw segment SP of 4.4 centimeters. Keep the point of compass on point P and taking 5.5 centimeters as measure, cut an arc. Now, keeping the point of compass on point S with 5.1 centimeter, cut the previous arc. Mark the point of intersection of both the arcs as E. Now join SE and PE. Thus, triangle PSE is the required triangle. Now draw any ray SA making an acute angle with segment SP. Divide the ray SA in 5 equal parts. Name them as S1, S2, S3, S4, S5. Now join PS5. Keep the point of compass on S5 and draw an arc. Taking the same distance, cut an arc from point S3. Now measure the distance of the arc drawn at point S5 and cut the arc drawn at point S3. Draw a line passing through point S3 and touching the segment SP at point T. Again, keep the point of compass on point P and draw an arc. Taking the same distance, cut an arc from point T. Now measure the distance of the arc drawn at point P and cut the arc drawn at point T. Draw a line passing through point T and touching the segment SE at point V. Thus, we get the required triangle TSV similar to triangle PSE. Example 5. Triangle LMN is similar to triangle LQP. In triangle LMN, LM is equal to 4.2 centimeters. Angle L is equal to 50 degrees. LN is equal to 3.6 centimeters and LM upon LQ is equal to 4 upon 7. Construct triangle LQP. Solution. Draw segment LM of 4.2 centimeters. Draw an angle L of 50 degrees. Keep the point of compass on point L and taking 3.6 centimeters as measure, cut an arc at point N. Now join NM. Thus, triangle LMN is the required triangle. Now draw any ray LA making an acute angle with segment LM. Divide the ray LA in 7 equal parts. Name them as L1, L2, L3, L4, L5, L6, L7. Now draw ray LB by extending the segment LM and draw ray LC by extending the segment LN. Join points L4 and M. Keep the point of compass on L4 and draw an arc. Taking the same distance, cut an arc from point L7. Now measure the distance of the arc drawn at point L4 and cut the arc drawn at point L7. Draw a line passing through point L7 and touching the ray LB at point P. Again, keep the point of compass on M and draw an arc. Taking the same distance, cut an arc from point P. Now measure the distance of the arc drawn at point M and cut the arc drawn at point P. Draw a line passing through point P and touching the ray LC at point Q. Thus, we get the required triangle LQP similar to triangle LMN. Now let's solve exercise 3.4. Question 1. Triangle ABC is similar to triangle DEF. In triangle ABC, AB is equal to 5.2 centimeters, BC is equal to 4.6 centimeters, angle B is equal to 45 degrees, and BC upon EF is equal to 2 upon 3. Construct triangle DEF. Solution. Here, it is given that triangle ABC is similar to triangle DEF. Therefore, AB upon DE is equal to BC upon EF is equal to AC upon DF is equal to 2 upon 3. And as angle B and angle E are congruent, so their measure would also be same, that is 45 degrees. Here we got the measure of one angle. Now let's find the measures of side DE and EF. To find the length of DE, it is given that AB upon DE is equal to 2 upon 3. Now, by substituting the value of AB as 5.2, we get 5.2 upon DE is equal to 2 upon 3. Therefore, 5.2 into 3 is equal to 2 into DE. Therefore, DE is equal to 15.6 divided by 2. Therefore, DE is equal to 7.8. To find the length of EF, it is given that BC upon EF is equal to 2 upon 3. Now, by substituting the value of BC as 4.6, we get 4.6 upon EF is equal to 2 upon 3. Therefore, 4.6 into 3 is equal to 2 into EF. Therefore, EF is equal to 13.8 divided by 2. Therefore, EF is equal to 6.9. Now let's look at the construction. Draw a segment EF of 6.9 centimeters. Keep the protractor on point E. Measure 45 degrees and draw angle E. Now, taking 7.8 centimeters as measure and keeping the point of compass on angle E, cut an arc. Mark that point as D. Now join DF. Thus, we get the required angle DEF. Question 2. Triangle LMN is similar to triangle XYZ. In triangle LMN, LM is equal to 6 centimeter. MN is equal to 6.8 centimeter. LN is equal to 7.6 centimeter and LM upon XY is equal to 4 upon 3. Construct triangle XYZ. Solution. Here, it is given that triangle LMN is similar to triangle XYZ. Therefore, LM upon XY is equal to MN upon YZ is equal to LN upon XZ is equal to 4 upon 3. Now let's find the measures of sides XY, YZ and XZ one by one. To find the length of XY, it is given that LM upon XY is equal to 4 upon 3. Now, by substituting the value of LM as 6, we get 6 upon XY is equal to 4 upon 3. Now, by cross multiplying, we get 6 into 3 is equal to 4 into XY. Therefore, XY is equal to 18 divided by 4. Therefore, XY is equal to 4.5. To find the length of YZ, it is given that MN upon YZ is equal to 4 upon 3. Now, by substituting the value of MN as 6.8, we get 6.8 upon YZ is equal to 4 upon 3. Now, by cross multiplying, we get 6.8 into 3 is equal to 4 into YZ. Therefore, YZ is equal to 20.4 divided by 4. Therefore, YZ is equal to 5.1. Lastly, to find the length of XZ, it is given that LN upon XZ is equal to 4 upon 3. Now, by substituting the value of LN as 7.6, we get 7.6 upon XZ is equal to 4 upon 3. Now, by cross multiplying, we get 7.6 into 3 is equal to 4 into XZ. Therefore, XZ is equal to 22.8 divided by 4. Therefore, XZ is equal to 5.7. Now let's look at the construction. Draw a segment YZ of 5.1 centimeter. Keep the point of compass on point Z and taking 5.7 centimeters as measure, cut an arc. Now, keeping the point of compass on point Y with 4.5 centimeters, cut the previous arc. Mark the point of intersection of both the arcs as X. Now join XY and XZ. Thus, triangle XYZ is the required triangle. Question 3. Triangle RHP is similar to triangle NED. In triangle NED, NE is equal to 7 centimeters. Angle D is equal to 30 degrees. Angle N is equal to 20 degrees. And HP upon ED is equal to 4 upon 5. Construct triangle RHP. Solution. In triangle NED, it is given that angle D is equal to 30 degrees and angle N is equal to 20 degrees. Therefore, angle E plus angle D plus angle N is equal to 180 degrees. Therefore, angle E plus 30 degrees plus 20 degrees is equal to 180 degrees. Therefore, angle E is equal to 180 degrees minus 50 degrees. Therefore, angle E is equal to 130 degrees. It is given that triangle RHP is similar to triangle NED. Therefore, RH upon NE is equal to HP upon ED is equal to RP upon ND is equal to 4 upon 5. Here, angle N and angle R are congruent, so their measure would also be same, that is 20 degrees. And angle E and angle H are congruent, so their measure would also be same, that is 130 degrees. Here we got the measure of two angles. Now let's find the measure of side RH. To find the length of RH, it is given that RH upon NE is equal to 4 upon 5. Therefore, RH upon 7 is equal to 4 upon 5. Therefore, RH is equal to 28 divided by 5. Therefore, RH is equal to 5.6. Now let's begin the construction. Draw a segment RH of 5.6 centimeters. Keep the protractor on point R, measure 20 degrees and draw angle R. Now, again keep the protractor on point H. Measure 130 degrees and draw angle H. Let the point of intersection of both the angles be point P. Thus we get the required angle RHP. Question 4. Triangle SHR is similar to triangle SVU. In triangle SHR, SH is equal to 4.5 centimeters. HR is equal to 5.2 centimeters. SR is equal to 5.8 centimeters and SH upon SV is equal to 3 upon 5. Construct triangle SVU. Solution. Draw segment SH of 4.5 centimeters. Keep the point of compass on point S and taking 5.8 centimeters as measure, cut an arc. Now keeping the point of compass on point H with 5.2 centimeters, cut the previous arc. Mark the point of intersection of both the arcs as R. Now join SR and HR. Thus, triangle SHR is the required triangle. Now draw any ray SA making an acute angle with segment SH. Divide the ray SA in 5 equal parts. Name them as S1, S2, S3, S4, S5. Now join HS5. Keep the point of compass on S5 and draw an arc. Taking the same distance, cut an arc from point S3. Now measure the distance of the arc drawn at point S5 and cut the arc drawn at point S3. Draw a line passing through point S3 and touching the segment SH at point V. Again, keep the point of compass on point H and draw an arc. Taking the same distance, cut an arc from point V. Now measure the distance of the arc drawn at point H and cut the arc drawn at point V. Draw a line passing through point V and touching the segment SR at point U. Thus, we get the required triangle SVU similar to triangle SHR. Question 5. Triangle AMT is similar to triangle AHE. In triangle AMT, MA is equal to 6.3 centimeters. Angle MAT is equal to 120 degrees. AT is equal to 4.9 centimeters. MA upon HA is equal to 7 upon 5. Construct triangle AHE. Solution. Draw segment MA of 6.3 centimeters. Draw an angle MAT of 120 degrees. Keep the point of compass on point A and taking 4.9 centimeters as measure, cut an arc at point T. Now join MT. Thus, triangle AMT is the required triangle. Now, draw any ray AP making an acute angle with segment MA. Divide the ray AP in 7 equal parts. Name them as A1, A2, A3, A4, A5, A6, A7. Join points A7 and M. Keep the point of compass on A7 and draw an arc. Taking the same distance, cut an arc from point A5. Now, measure the distance of the arc drawn at point A7 and cut the arc drawn at point A5. Draw a line passing through point A5 and touching the segment MA at point H. Again, keep the point of compass on M and draw an arc. Taking the same distance, cut an arc from point H. Now measure the distance of the arc drawn at point M and cut the arc drawn at point H. Draw a line passing through point H and touching the segment AT at point E. Thus, we get the required triangle AHE similar to triangle AMT.